Hello, in this video we are going to be talking about disc clutches and how they work, their importance, and all that fun stuff. So let's get into it. So with this picture right here, it's actually a good visual to look at because it's fully broken out of all the different pieces of the clutch. Um, and so this is just a good visualization to look at and we're going to go into some more detail. So this is a simpler view, and so with the clutch, um, how it works is the purpose of it is to deliver power from the engine to um, the transmission, typically, and with it, it can also it stops the flow of energy. So typically in a manual car, you'd have a simple clutch like this, and as we learned in our lab, we saw one similar to this where it simply was just used to give energy to the transmission and stop the energy flow. And the way this works is that when you push the clutch, it puts pressure on the pressure plate, which separates the clutch disc from the flywheel. So you would typically press like a pedal on the car if it was a manual car, and you have a fork which would push down on here, right? Your clutch fork, something, um, and then that would cause for the clutch disc to lift off the flywheel, and that would stop the rotation because this is rotating and this is rotating and this is sandwiched in between. And so that um, when they are compressed, it's all rotating as one. But when they're separated, this piece, the flywheel, and the clutch and the pressure plate are both rotating separately because they're separated by the different shafts. And we can see that here. So the drive shaft is what's coming from the engine, and then on the other side is the drive shaft which goes to the transmission. And the way that it would stop them is how I showed you here, because obviously you don't always want the power flowing to the transmission if you don't want to move, for example. So this is the friction material that would be lined in between this small plate. And the reason why I said this was a good picture is because it shows you all the different layers. So these are very simple pictures of what a clutch would look like, but here is kind of the realistic picture because there's multiple um, friction discs and layers to the clutch of the different plates. Um, and so you need a high friction material because when they're pushing together on and off and for a long period of time, it needs to last, right? And it also needs to slow down from high RPM, right? Which is going to build up heat, and so then there's a lot of properties of the materials that come into picking the material you want. But we're more focused on the physics of how it works. And here you can just see some like a cross-section view of it and where the radiuses are of the inner radius and outer radius, which we're going to be looking at later. This is a more complex view of, I guess, this, where it shows you everything relating it, um, like all the pieces put together. So we won't get too much into that, but this is just a good visualization. And also something to mention is that these springs here are used for stopping the vibrations, which isn't that important for what we're doing, but it's fun fact, I guess. So there's two cases to look at when dealing with these. The first case is uniform distribution of the interface pressure. Um, and applies to when you have a brand new clutch. So there's been no wear on it, there's been nothing. It's just perfect from the factory. And so here we're going to take a look at each equation. These are the equations. We're going to look at the variables and what they mean. So F is the total normal force acting on the area of contact. P is union level of interface pressure. T is total friction torque that can be developed over the entire interface. R is the radius of the friction of the surface, and then it has the outer and the inner, as we were looking at right here. And then we got N, which is the number of interfaces, and then F, which is the friction coefficient. And then here are all our different equations that are useful for when solving a problem of this type. So now we're going to look at the second type, which is uniform rate of wear at its interface. So as the name says, it is used for when you have uh, a clutch that has been under wear, so it's been used before, it's not brand new. And this is the case that is probably more like frequent that we're going to be looking at because well, I mean, typically they're going to be used, right? So, pretty much the same variables, except for that there's Pmax, which is the greatest pressure at which occurs at the inner radius. And then we have C, which is a constant. So then you have your Pmax times your inner radius, which gives you C. And these are all your equations to use for when you're talking about uniform rate of wear. And lastly, we have one more equation, which can help you determine your inner or outer radius, depending on which one you have. You use this equation here. And it's a design parameter of the clutch. So, and then the last thing here is this chart, which is used for determining the dynamic friction coefficient. So depending on what type of friction material given, it will tell you the range of friction that you have. So if you have wood, for example, you're going to have 0.12 to 0.16 range for your friction coefficient. And that is it. So I hope this was helpful and you understood my explanations of how the clutch works.